I got this thing, this Dagger 6-wheel drive Wild Thumper. And I was putting it through its paces, but unfortunately I ran into a wheel seizure. So I figured the cool thing to do would be to take apart the wheel and figure out what the hell's wrong with it, right? Alright. So this is the 34-to-1 motor. I got a replacement, but the gear ratio is 75-to-1. So, although there's the possibility that there may be some usable gears of the same pitch. So in the 34-to-1, there's the output gear on the motor, and it's got 1, 2, 3 compoundments on the inside, and then or on the outside, and then it reduces further in here. The order of operations here is from the motor: small gear, bushing, small gear, large headed gear, then the gearbox middle, and then on the inside either large headed gear, bushing, drive shaft. And that's the 34-to-1. And the culprit here of the seized wheel is 1, 2, 3, 4 teeth having been sheared off. To replace it, I was handed a 75-to-1 gear motor, which will not work with the different gear ratios, but there may be gears inside in that gear train that I can use for this purpose. Externally, it's identical other than the fact that it's marked as a 75-to-1 at 131 RPMs versus the 34-to-1 gear motors, which is the 293 RPMs. They're both 6-volt motors, and I'm not certain of the amp draw in various conditions on the motor itself. Entry is gained to the gearbox much in the same way. Open it up from the motor side. Now in this gear chain there are 4 gears versus the 34-to-1's 3 gears. Gear, bushing, gear, gear, gear. I took the bushing with it from the inside. Then we go through the retaining wall. Large gear. Looks like one of the ones that I need to replace, and then the drive shaft. The drive shafts have the same gear pitch. The transitional gear has the same gear pitch above and below. And I have 2 of them, which means both of my busted gears may be replaceable. It's also important to note that these gears are ferrous in material. These are not plastic gears. The 75-to-1 now has the honor of bearing the stripped gears. Okay, that got the 34-to-1, the T-pipe for the 34 to 1. And then if you have an arbor press, it'd be good to press this into it. I don't, so I'm going to use myself. Alright, that is locked into place. The rest of the parts for that. These are the axle that mount it to the chassis. And these are the clamping bolts and their responding locking nylon nuts. What I would like right now more than anything is an M3 hex wrench. That'll do. This will be the bottom. Put the screws to hold the ankle axle in here. Now have an intact gear motor. T-pipe ankle assembly. So this is kind of a neat little thing with its suspension. Is there's a tie cable and a torsion spring that allow these two to speak to each other. So we've got a good spring-loaded suspension there. It bothers me that I have this group of screws and I'm not entirely certain on where they go when I put this thing together. Yes, I do. They go there. Thank you. And these pivot about these screws here. This is the fun part about robotics, is fighting spring tensions back into place. There's not as much physical grappling with just pure electronics that I sort of lament when I do that. Alright, so there's that suspension system. That's still too tight. So it will be this pair, speaking to this motor, caution, try this at home. Yeah. Talk to me. Yes! Now I've got this head to put back on. And by head I still mean part of the motor. Wish I had more desk. Poof. Okay, through the plate. Which side's hex? That side is hex. That side is screw. Not dimensionally sensitive. Don't care. Standoffs facing up. Outboard. Yes. Aligned like that. Rotate 62 degrees. Alright, there we go. Facing the right direction and not upside down. Now it's time to torque it down. Get the static where it wants to be static. Dynamic where it wants to be dynamic. That is the front end assembly for the Wild Thumper 6-wheel drive, 34 to 1. So So now that structurally is back in place, let's manage the electrically. Goodly bit of tension does not pull that out. Now for the ground channel. Right one motor is now wired to the main bus. The same for left one, positive, and negative or ground. And rebind. As I look at it, it is going to be backwards. Left is right, right is left. B1. Now what I'm doing now is plugging the motor lines into the shield on my microcontroller. It's currently an Arduino Uno platform running Arduino 022 through a Monster Moto shield sold by SparkFun. So let's finish getting these feet back on here. Ensure proper orientation. Chevrons. Ah, it's good to hear that turning again, feel it turning again. Awesome. Power interrupt switch to the logic. PlayStation controller with sloppily wired together breadboard to control it. So I've hacked the end off of a PlayStation controller here. Wired the pin out to talk to the same microcontroller that is driving the motor controller. According to my pinout, brown 2. It's just a matter of following the pinouts. Uh-oh. No, that's cool. That's cool. Put the robot up on blocks. Power to the motor controller. Alright. Power interrupt on. Analog light on. Excellent. And that is how you repair a busted ankle. Alright, so that works.